Hey folks, it's Mr. Defali once again. Welcome back to part 2 of special right triangles. In the first part, we dealt with 45, 45, 90 triangles, and I went through some examples with you on how that works. And in this video, we will focus on 30, 60, 90 right triangles. A couple things I want to point out. There's a special relationship between the three sides that's different from 45, 45, 90. First, this triangle is not a right isosceles, and I know that because A is obviously longer than B, though C is the longest of all three. The angles that we're dealing with are 30, 60, 90. The 30 degrees, being the smallest, must go in the smallest space available for an angle to fit. And so that would fit right where I just wrote it a moment ago, 30 degrees. Which means that the 60 degrees must be here, and of course that 90 degrees is always indicated by a little square at the corner there. Now, the smallest angle opens up to a side opposite from that angle, and that angle, or that side, if you follow the dots here, that side is side B. Now, because 30 degrees is the smallest angle, that means that B is therefore the smallest side. So this is, by definition, the smallest side. Okay, now 60 degrees would be the next highest measurement here, and because 60 degrees is the medium measurement, that means that the side it stares at would be side A, and side A would therefore be the medium length. So medium length, or I'll write side to be consistent. So medium side, okay? And I'll throw in this word for good measure. So we are talking about lengths. So medium side length, smallest side length, and of course, like I already said, C is the hypotenuse, and the hypotenuse always wins. It's always the longest side, okay? So it's the longest side length. Okay, now not only that, but because of these relationships with each other, the values of these lengths go as follows. Side B, being the shortest, if you were to double that up, you would actually get the exact length of side C, which is the hypotenuse. So I can summarize this by writing it as follows. I could say that C, which is a hypotenuse, is equal to double the length of B. And if I compare B to A is longer than B, but A is not quite as long as C. So A is not twice the length of B. And this may seem a little counterintuitive because 60 degrees is double the value of 30 degrees. So you might think, well, if 60 is double of 30, that should mean that A is twice or double the length of side B, but it's not. Because A is not as long as C, and C is the one that is twice the length of B, that must mean that the value of length A must be somewhere between B and C. And it happens to be this. If you take a look carefully on the right side, it's actually this. So the value of A is the value of B, but with this much more to it. So if you were to cut and paste side B onto side A, it would fit, but it wouldn't cover all of A. You would need an extra radical 3 more to stretch it out to be the length of side A. And so that's why A is equal to B radical 3, okay? It's radical 3 times longer than side B. So having said this, and having established these relationships, which you see over here, we can go ahead and go into some examples. Now, the first example I have is over here. And in this example, we have to look at what you're given and where things are placed. So I notice that my 60 degrees is here, which means that this is my medium length. And this must be my 30 degrees, which means that this is my shortest length. I'll just put shortest. And of course, 90 degrees is looking at A, which means that this is the hypotenuse, okay? or the longest. So knowing these things, I can go ahead and figure out what I need to. So being the shortest length, this 8 radical 3 over 3, if I want to get the value of a, all I have to do is remember the relationships, which go something like this. A will simply be double the length of the shortest side. And because the shortest side is 8 radical 3 over 3, what I get is a is equal to 2 times 8 radical 3 over 3, which when you simplify is 16 radical 3 over 3. And that's it. That's the value of a. For the value of b, I have to remember that b is somewhere in between the shortest and the longest sides. And b is radical 3 times longer than the short side. So to get that value, I would simply say this. I'm going to create a division here to separate my work. So b, being the medium, is equal to the shortest side times radical 3 more. Okay, so replacing what I have, the short side is 8 radical 3 over 3. So 8 radical 3 over 3. And I'm going to multiply that with my radical 3. When I simplify this, what I get is that b is equal to 8 times 3 over 3. And then this just means that these two 3's cancel out, and I'm left with 8. So this is the first example. In the second example, moving along, in the second example, again, I have to note what I have and where everything is placed. So in this second example, right away I notice that my 60 degrees is here, which means that the side opposite of that, which is here, this must be the medium length. X is opposite of 90, so that must be my hypotenuse, which is my longest side. And that means that we only have one thing left, and that is our 30 degrees, which must go here. And that looks all the way over here, which means this is our shortest. Okay, so now that I've established this, what I can do is figure out the math. So it looks like I'm given the medium length this time, and I have to work backwards to get my shortest length and then my hypotenuse. My plan of action is this. In order to get the hypotenuse, I must first know the length of the shortest side, because remember, the hypotenuse is double the length of the shortest side. So the shortest side is the key here to figuring this all out. So I need to start with my y. So I know that my medium is exactly radical 3 times the shortest side. So I'll replace the words with the things that I actually have from the drawing here. So my medium length is 7 radical 3. Radical 3 is still there, so I bring that down, and my shortest side is y. Now I need to solve this. There are two ways of doing this. So one way is I will solve it. One way is I will show you how to get the answer logically, okay? By pure observation. So the first way is to solve by dividing with a radical 3 here and a radical 3 right there, which means that these cancel out and so do these. And that leaves me with a 7, which is my value for y. Another way you could have gotten the same answer is if you notice over here, and I'll rewrite it like this. So y radical 3. The right side and the left side must be the same, which is why there's an equal sign there. So the question is, what would this need to be so that the right side ends up looking like the left side? Well, the answer to that is, if this y was a 7, then the two sides would be exactly the same. So in other words, my y must be a 7. Okay? By pure observation, we can figure this out. Okay, so, oops, sorry about that. Depending on what your teacher wants, you may have to show your work or justify your answer by observation by writing something down about how you got that. So now let's go ahead and get the x. Now that we have the shortest side, to get the value of x, we just double the length of the shortest side. So that means that x is 2 times 7, which is 14, and I'm finished. So I hope this video helped you out. Be sure to check out the other video before this one about 45, 45, 90 special right triangles. The properties for that one are different from the 30, 60, 90. So please stop by and check it out. And as always leave a comment if you have something constructive to say. And I appreciate you taking the time to watch. Thank you. Bye-bye.